Hello everyone, thanks for coming to this session. My name is Audrey Neveu, I'm full stack developer at saagie, and we are going to talk today about Micro Frontend. So we are going to look at the evolution of our application architecture. And to do so, I thought it might be easier if we take an example that we all know, the Java Pet Store. So at the time it was launched, around 2005, any languages it would have been written at this time, it would have been a classic end-to-end monolith. And then, front-end development became a thing. All of these fancy JavaScript frameworks that we all love appear. And at this time, we usually splitted our monolith in a front-end and a back-end application. And then microservices came in the game. And at this moment, usually we splitted our backend monolith into a shiny group of microservices, each one being in part of a specific domain of the application. So here, for example, it could have been the product service and the search service and the checkout service, etc. One interesting thing to notice here is the way our team organization is strongly tied to our architecture. So when we were having this end-to-end monolith, usually, we were just one team. And OK, so I've got a slide issue. Fine. So we're just one team, the Pet Store team. And then when we moved to the front and back applications, we were usually two teams, the front-end team and the back-end team. And when moving to the microservices organizations, we usually split our back-end teams into several smaller teams, all of them in charge of one part and only one of the application, or sometimes several if they are small enough. And that's the first benefits of microservices, because having small and specialized team, they're doing just one thing, but they're doing it well. And usually they're delivering faster too. Plus, microservices bring the freedom in your stack choices. If the product team wants to work with Java and the search team wants to work with React, it's fine. Microservices are also easier to deploy because when you want to deliver a new feature, you don't have to redeploy the entire stack. You're just going to deploy the microservices you updated, and that's all. For the same reason, they are easier to scale, because you're just going to scale the services which will be requested the more and not the entire stack. Oh, that's the missing slide. OK, thanks. So looking at our front and microservices split, we can think that finally everything is at its place and completely optimized, but it's not. It's not because, first of all, you now ended up with a front-end monolith, which is just as hard to maintain and involve that your back-end monolith was. And it's still not because you're still having this front-end team and back-end teams relationship. So it's a kind of strange relationship where one team is directly working for the customer and the others not. And now there is not just one backend teams, but there is several teams. They're working faster than before, and you still have just one front-end team in front of them, so kind of difficult. That's the reason why it's the time to move to the next step of evolution, which is Micro Frontend. The core idea behind Micro Frontend is that you should consider your application as an aggregation of feature. So we split the front-end monolith into several smaller components, and now we are keeping our smaller teams, but they are now in charge of the part of the domain, but end-to-end. That's a classic way of working for e-commerce companies, but not only. Facebook and Spotify are working this way too. Not all of them are sharing about the way they're doing it, but when they do, I strongly recommend you to have a look at it. So if we're looking back at our pet store, but a little bit better pet store, thanks to Antonio. So we would have a product team, which is in charge of this page, and it's the only one in charge of this page. And this team is going to use components provided by other teams, like the shopping cart menu provided by the checkout team, and the search bar, which is provided by the search team. And a very important idea behind Micro Frontend is that each team should be able to work with the framework they want, with the entire stack they want. So we can imagine here having the product team working in Angular, and the search team working with Vue, and the checkout team working with React, for example. So you still have small and specialized team, but now, and that's a big but, they are customer-focused team. So they only have one mission, and they don't have to care about what's happening in the rest of the application. Their only mission is to provide the better experience as possible in their part of the application. So you keep your small team's benefits, but now customer-centric. You still get this freedom in your stack choice, but now applied to front-end, which is quite a thing. And your teams are more autonomous in their development process. Because now you don't need to run the entire application on your laptop to work just on a single part. Plus, if, for example, the search bar component is broken by the last delivery, it has no impact on the rest of the teams. So your teams are more autonomous in their release of features, because now you don't have this, all these backend teams delivering new features and the front-end team having to integrate them as fast as possible. Now each team is in charge of the integration of the feature end to end. And it makes also your application's evolution easier, because when you plan to refactor the application, you don't have to refactor the entire monolith in one move. You can simply refactor it piece by piece and plan it. So that was the theory. Now let's have a look at the real-life study case, Data Fabric. Data Fabric is the name of the saagie-ul product. It all started with the manager, which is basically big data orchestrator. So data scientists and data engineers can upload, run, pipeline all their extraction and processing data jobs. It was launched in 2015, so written in AngularJS. Then came the governance, which is a tool more oriented to chief data officer and all business-related people. It helped them documenting their data, basically. This one was launched in 2017, so it was written in Angular. And then arrived operations, which is a little bit different from the two others, because this one is not tied to a platform/data lake. This one is an overall application, which allows the customer to monitor the health of every platform it owns. And at this point, 1 year ago, we quickly realized a few things. First, that we have to refactor the manager to extract common services. Then, that we were needing other applications like the operations to enhance the overall experience of the customer. And that all of these applications, including those three, were needed to be presented in a single application. So 1 year ago, we started working on the version 2 of Data Fabric. On the human side, it went smoothly. We merged our two teams into one big micro teams, which were working in one part of the application. On the technical side, it was a little bit more difficult. So we made a first try with layout. Then we made a second try with something we called Galaxy. And we made a third try with layout as lib, which is now in production since July. And all of these experiences are what we are going to talk about now. So before we jump into technical details, just to have in mind what we were targeted, that's the version 2 of Data Fabric. So you got a first lateral menu, which is called primary nav, and allows the user to navigate from platform-related applications to others, like governance and manager. Then you got a top bar component, which allows the user to navigate through non-platform-related applications, like resources, operations, etc. Then you got a user menu, and the main component is the application itself. And before going directly into techniques, I want to say a word about design system, because there is no point to make micro frontends if you're not going to provide a consistent user experience to your users. So basically, a design system defines a set of styles which are going to be applied to your components all over your application. Because you know, copy-paste CSS does not work at all. This one is called saagie-ul. It's available on NPM. It can't be reused for commercial purposes, but feel free to have a look at it, at the way it's built, to get inspired for use. So our first try, Saagie layout, is completely based on the microfrontend.org website approach. So I'll give you all the links at the end, don't worry. It's a classic micro frontend architecture, as we've seen previously, but it completely relies on web components, which means that our applications stay in their own framework, but are going to be encapsulated in web components. Quickly, if you're not familiar with web components, they rely on 4 specifications, which can be used on their own, but combined allow the developer to define your own tag, thanks to custom element, whose style are encapsulated in the shadow DOM and completely isolated from the rest of the application, where you can define HTML templates that go use.page load but can be instantiated later on. And you get a consistent way of declaring them thanks to OS modules. So declaring a web component is pretty simple. You're going to create a JavaScript class which extends HTML element. And in this class, you will have access to several methods defined by the APIs to manage the lifecycle of your component. So we've got the connected callback method, which is called when the element is attached to the DOM, the disconnected callback method, which is called when the element is detached from the DOM, and the attribute change callback, which is called each time an element, as I've seen, its value changed. And that's not in the specification, but that's something you will see quite often. You get a random method, which is used to declare the markup of our component, because we usually call it twice by the constructor and by the attribute change callback method, so we just don't want to duplicate code. And finally, outside of the class, you're going to define a component by calling the custom elements API and saving it in the custom element registry with its tag and the name of the class. Now in your HTML page, it's quite simple. You're going to import this component, and you're going to declare it as you would do like with any other tag. And as you probably expect, your component who works with even older version of browsers, but all versions of browsers generally, you would use a polyfill. This one is the most stable, reliable at the moment. So in the case of Saagie layout, it means that those 3 menus we've seen previously became web components, and that the main components basically is the entire application we've seen previously encapsulated in a web component. So, whereas the AngularJS application or the Angular application. How do you transform an existing application into a web component? With AngularJS, it's very, very simple. You're going to declare your web component as you would do normally. And in the render method, you're going to create a div. And this div is going to have as parameters the ng-app and the ng-controller of your application, basically like you would do normally. And then outside of that, you just register your component, and you're done. It's even more easier with Angular, because with Angular, you just have to take your top-level component, and you're done. On the application side, so it's a very simple JavaScript application. In the main page, we're going to import those 2 components, and we are going to import our saagie-ul library, the design system we've seen previously. And then we're going to declare an SLA board tag. And this SLA board tag is in charge of rendering and configuring all subcomponents. So it declares the SLA top bar and the account menu and the primary nav, and then it declares something which is the page you're seeing there. And this page variable is obtained by calling the getPage method. And the getPage method is going to look at the path, and in function of the request the user has made, is going to send back the data manager component or the data governance component. And then you register it like any other web components, and you're done. This approach has several benefits. First of all, it gave us a very consistent user experience. No matter if you were on the governance application or on the manager application, you were still having the same menus. Plus, it gives us the possibility to display several components on the same page if we wanted to. And we were completely independent on the deployment side, as Saagie layout lifecycle was completely outside of manager and governance lifecycles. But we didn't integrate other applications in this try because we quickly realized that there were some blocking issues for us. So first of all, it's not a true single-page application, which means that every time you were moving to one application to the other, it completely reloaded the application. And it has terrible performances. And that was due to the fact that we were not just binding and unbinding components. We were binding and unbinding components with application. And those two applications were coming with their own router and their own version of the saagie-ul library, their own version of Babel. So first of all, you got a performance issues because you're going to load twice same libraries. And then you can quickly run into bugs because if, for example, saagie-ul is not in the same version between governance and layout, you have bugs. So we got these high dependencies, on libraries between apps, which was very blocking. And we were also having this routers management issue. Because each application is coming with its own router based on hatch, meaning that Saagie layout application has to know about every possible path of those two applications and others, if we wanted to integrate others. So you introduce a strong coupling between layout and governance and manager, and we didn't want that. And last but not least, it implies to run the entire stack locally, which is neither something you really wanted to do when some HDFS is implied, nor something you can do. We're using free APA, and it doesn't run on OS X. So we made a second try called Galaxy. And I'm not going to spend a lot of time on this try because it's basically the same approach as the previous one. But this time, all components are React fragments. And the plan was, in the second time, to use Tailor, which is a library to stream fragments to improve the loading time of the application. The pros we were seeing in this approach, that it gave us the possibility to share entire components between applications and not only styles. And that we would have had a centralized router system, giving us the possibility to have some components lighter, simpler. So that was the very good point of that. But on the other side, we were still having this high dependency issue between apps. And it was even worse because it was not only on libraries, it was only on React version. So, for example, if the security app, which is the only one which has been integrated into, wanted to use a React component, which is not in the React version of Galaxy, it means that you have to update the React version of Galaxy and to update the React version of every other application. That was not possible. So we moved to our third try. And for the third try, we decided to reverse the logic. So we keep the components we've seen previously. We keep our web components, but we moved them to a small JavaScript library. It's pure JavaScript to keep it as lightweight as possible. So as any other libraries, it could be installed through NPM, which means that existing applications were still working exactly the same as before. They just have to declare this new library, and use it whenever they want. On the application side, so here it's the main HTML page of governance. So you get this main component, the top component we've seen previously, and you're just going to encapsulate it into the Saagie layout component, which is hidden by default. And in the main page of the application, we're going to first look if we're in legacy mode or not. And if we are not, well, we're going to call a class, the load layout data class, call the init method and pass it all proper parameters. And then we're going to call our Saagie layout component and remove the hide attribute to make it visible to our users. On the library side, so it's a very, very simple library again. The main JavaScript page only imports its subcomponents and then export the load layout data class we've seen previously. And this load layout data class is, in fact, the one that is going to be in charge of configuring every menus according to the user rights and profile. So this method is going to first take the saagie layout component through the DOM, and then make all API calls needed to get all the user rights and profile. So for example, one it has called the load write method. It's going to call the set platforms method with the list of platforms the user is allowed to see. And then the set platforms method is going to change the attribute, the value of the platform list object attribute, to the saagie layout component. So this component, the layout component, is now only in charge of basically updating its sub-components. So it has a connected callback method, as we've seen previously, with an initRender method. And in the attribute change callback method, it's going to look at every one of its attributes. And in case of a change, it's going to update the top bar or the primary nav or both, etc., according to users' choices. So as you can see, as you have probably noticed, we get an initRender method and not a render method. And the reason why is because we don't want this method to be called twice. So this method, like we've seen in the layout application, is declaring its markup. So it's declaring the primary nav and the saagie top bar and the user account menu, etc. But this time, you get this inner HTML variable. And this variable, in fact, is our data governance application, our data governance tag that we encapsulated into the saagie layout application. That's the reason why we don't want to call this method twice, because we don't want to reload the application or perhaps crashing it. For the same reason, we are going to look if the saagie layout custom elements is already declared or not before declaring it to the custom elements registry. So, with this approach, it's not a single page application at all. And we can't aggregate components anymore. And that's not a problem. The thing is, we were not in the right use case for the first two tries. Try number 1 and try number 2 are real nice when you wanted to aggregate components into the same page. Here we are much more in an aggregation of small single-page application. And you can hardly avoid to reload pages when you're changing application. So considering that those 2 points are not a problem, it's definitely the best solution for us. First of all, it's way more faster to integrate. It took me like 1 day to integrate it end-to-end, deliver in production, etc. in governance. It's way more faster, obviously. Loading a library in an application is way more faster than loading an application inside an application. But it's true, it can result in a possible inconsistent user experience. If the library team is delivering a new version of the library with a new menu item, for example, in the primary nav, until the moment I update my version in governance of the layout lib, I will not have this menu displayed. So I may have a little inconsistency between manager and governance. But at least it works. And it works even if something is broken on the other side. This way, we get a complete independency on both development and deployment side. If this new item menu introduces a bug, until the moment I don't upgrade my version of the library, I don't have the bug. So I just have to wait, for the library team to upgrade the library, and then I will directly upgrade on this new version, and at least nothing was broken on the governance side. But it's still true that in case of breaking changes, you have no other choices than to upgrade the version of the library in each application. But on the other hand, we have resolved the libraries conflict. So we don't load a library twice at first. And before upgrading my version of the library, I'm just looking at the version of the saagie UI it's using. And if it's not the same than mine, I'm going to upgrade my version of the saagie UI library, and then I'm going to upgrade the version of layouts lib, and it's fine. And last but not least, as you understand, it was pretty important for us, it can be run on its own. You don't need to run the entire stack to test it. So at the end, it was very, very good experience for us, because we've been able to refactor this big guy, the manager, first by extracting the security and then by delivering the new project and jobs application. And by the end of the year, we would have delivered 4 new applications. So that's a big change in our rhythm, you know. So some best practices. If you want to try the Micro Frontend approach, think of your use case first. Are you going to make an aggregation of components? Do you really have a use case where you're going to expose a component coming from another team in your own page? Or are you going to make an aggregation of single-page application? Because as you've seen previously, it makes a big difference. Then take care of your design. So as we've seen first, design system is important, but keep in mind that you are going to load components coming from different applications. So it may result in higher loading time. So there is several little tricks that are really not expensive to implement, but can make a big difference on the user experience. Have a look at Optimistic UI, have a look at skeletons. They are really, really easy to implement, and they will give a better experience. Then share resources, not runtime. Even if you are going to use the same stack, the same framework for all your stack, don't share your runtime. Don't rely on shared state and global variable and all that kind of stuff. It will end very badly. But on the other hand, feel free to share every common libraries. Feel free to share fonts and CSS and all that kind of stuff. And feel free to share API calls, which are common to all the applications, like we are doing with the rights and profiles calls. To go further, I would really, really recommend that you're having a look at the microfrontends.org website, which is the one which describes the approach we've tried on the first application, the saagie-ul application. So this website is held mainly by AngularJS, but not only, who gave a really nice talk at the beginning of the year. And there is also a GitHub repository with 2 demonstrations, one with pure web components and one with my components, with web components, sorry, and server-side includes. And server-side includes are really something you really want to have a look at if you're going to aggregate components. Then you can also have a look at this article, Experiences Using Micro Frontends at IKEA. It's not going enough deeper into details to my taste, but you know, it's their kind of own recipe. So still a very, very interesting read, I recommend. You can also have a look at Project Mosaic, which is a set of library and services open sourced by Zalando, all designed to make Micro Frontend. And you can also have a look at a single SPA, which is still another approach to make single-page application with various frameworks. So we have 2 minutes left for questions. I think there is one.
Why are you not using slots with custom elements?
Slots with custom elements? What do you mean by slots? Because it was too, it consumes too memory. It was too heavy, so we don't use. Oh, yeah, sorry. The question was why are we not using Shadow DOM inside of the library, and that's the reason why. Yeah, it was too expensive in terms of memory, so we didn't use it. Any other question? Okay. Well, anyway, I'll be here all week, so feel free to come and say hello and ask your question if you get one. Thank you very much for listening, and if you want to give feedback, I'll be happy to read. Thank you.